About permutations and combinations. You guys are going to be learning how to determine how to arrange items mathematically. Okay? How many different ways are there to select three activities in a particular order? Or how many ways can you select 3 days out of the week? Okay? That's what we're going to be looking at. So we'll go back to the pod after we've gone over the lesson today, so then that way you can see how many different ways were there to select those three activities in those 3 days. Okay? So to start it off, I'm going to give you guys another example. Okay? Don't want you to write this one down, but it's a little bit easier than the do now. Okay? I want you to look at this example that says, suppose there are three towns, P, Q, and R, linked by roads as shown. How many different ways are there to get from P to R via Q? Okay, so take a look at this picture and determine how many different ways can I start at P and get to R. And yes, I have to go through Q. So don't say anything out loud. Think for yourself. So, volunteer. Muhammad, how many? It is 6. It is 6, okay? Very good. Now, how'd you get 6?
Started from way, so from P, I just started downward.
You went down, okay?
Yeah. So then when I was on Q, I just I could take a path up or down to the center.
Mm-hmm.
So that's 3 so far.
Okay, so by going down, I can either go up through the middle or go down, and so then that gives you 3 options, okay?
And then I just, start from P again and gone up again.
Mm-hmm.
And then I can go up again or through.
So then I gave you another 3, right? Yeah. Okay, so basically, 6 is correct. You basically had 2 options to get from P to Q, and then 3 options to get from Q to R, right? So how can I get 6 from 2 and 3? Multiplying, right? Did anybody notice that, or did we actually go through the pathways to get there? Went through the pathways? You noticed that? Okay. So if I follow that same logic of there being 2 ways to get from P to Q and 3 ways to get from Q to R and multiplying them, you can figure out the number of different ways to go from those 2 towns. Okay? So, same concept, same logic. What about now? How can I get from P to S via Q and R? So what's the answer? Which one is it? 24. Because how many ways are there to get from P to Q? There's 3. How many ways are there to get from Q to R? 4. And then how many ways are there to get from R to S? 2. And we multiply all of them together. So 3 times 4 is 12, times 2 is 24. So there's 24 ways to get from P to R, right? Okay. So that idea is known as the product principle. Okay? That is known as the product principle. If there are m ways of performing one operation, and then there are n ways to perform a second type of operation, then there are m times n different ways of performing those 2 operations in succession. So to get from P to Q, that was one operation. Q to R, that was the second operation. So you can multiply them together, hence product, to find the number of ways that you can get from one to the other. So this is a common question on the ACT and the SAT, okay? One of their favorite questions to ask you on the SAT is, you have a menu. You have all these different options for an entree, a main course, or a dessert, okay? And then I'll ask you, how many different meals can someone order if they order an entree, a main course, and a dessert, okay? Usually around like the first 5 or 6 questions. They usually ask that in the ACT. Okay, it's considered more of an easier type problem. Using the product principle, you can figure out how many different meals this one person can order. Okay, so take a moment, figure it out. How many different combinations are there for a person to order? Okay, someone. Julia. How'd you get 30?
2 times 5, and then times 3.
Very good. 2 times 5 times 3. So yes, that would give you 30 different options. Did you guys get 30? Okay, good stuff. Let's try this one. This is another common one. Okay, how many different alphanumeric number plates for motor vehicle registration can be made if the first 3 places are letters from the English alphabet and the remaining 4 places are digits 0 to 9? So in other words, how many different license plates can you create? All right, so I'll give you guys a little bit longer than normal to figure this one out and discuss if you need to. Okay, so I think I've heard a few different things. Okay, who wants to volunteer their answer? Go ahead.
3,120.
3,120? 3120?
I'm afraid to protest.
You're afraid to protest. Why?
Well, I got 100.
So the answer to this one is your number that's in the millions. And what Muhammad explained, I mean, if you can't see it in the way of like how he was explaining it verbally, there was a picture as well. It really is, you do have 3 spots that need to be filled by 3 numbers, or 3 letters, right? Need to be filled with 3 letters, okay? And because none of them are, you can only use the number 1 time, that is 26 there. Same thing with the numbers. You have 4 numbers that need to be filled. They could be repeated. They all could be 1s. They all could be 2s. They could be 0, 1, 2, 3. They could also be 3, 2, 1, 0. So no matter what, there needs to be 10 numbers in those spots. So yes, that's 26 times itself 3 times, and then that's 10 times each self 4 times. And then what do you do to those 2? You multiply them together. So that number is, read from left to right.
175760000.
So 4 or 5 zeros.
I think 5.
4 zeros.
4 zeros. So yes, that's how many different ways there are to get a license plate. And if you think about it, in the state of Florida, you have 3 letters, and I believe it's 3 numbers. And so that's why no one's going around with the same license plate. Okay? You have that many different ways that you can have a license plate. And this is, with more options. The product principle. Does everybody understand? Very common on your SAT. Okay? Now, take that logic, let's take it up a notch, okay? Now, how many different ways are there to get from P to Q? Okay? So take a look at this, discuss, and then as a class, I want you to come up with a consensus on the answer and the why. So let's see. I think you have discussed it amongst your individual sections. Now come together. Come to a class number. So how many ways? There are 14. Using that same logic, okay? There's only if you have to make a decision. From P, am I going to go A or D? Either way, that's still one path that you're traveling. So if you decide to travel A, there's 2 ways to get from A to B, and then there's 3 ways to get from B to C, which make a total of 6 ways if you went along the top. Because again, there's only one way to get from C to Q. Also on the bottom, once you decide that you're going to go down to D, there's only 4 ways to go from D to E and 2 ways to go from E to F. 1 way to get from F to Q, which make a total of 8. So yes, that's 14 ways to get from P to Q. Because we had a choice of going to either A or D, this is known as the sum principle. Okay, so we do incorporate a little bit of the product principle if we went along one path, but because we have 2 different ways that we can get initially from P to get to Q, you have to add in the other sets of options. Okay, and that is known as the sum principle. Today is all about different arrangements, okay? Does that make sense? Yeah? Okay. Okay, so using that logic, let's take a look at a different type of map, okay? How many different paths lead from A to B? I want you guys to figure this out. How many different paths lead from A to B? It is 14. Yes, okay? Following the same logic, right? All of these, okay, it's one route to get to that next node, right? But if I go up, I have 2, and then 1. So what do I do to all those? You multiply them together. 1 times 2 times 1 is 2. Following suit, if I go through here in the middle, I have how many ways? How many ways? How many ways? Multiply them all together and I get going down. 1, then, and then multiply them together to get, and then going down, and then, for a total of 6. So at the end of this, I'm going to add them all together, right? And to get what? 14. Okay? Good stuff. Here's another one. Michelle rolls a die. Okay? If she rolls an even number, then she's going to pick from bag A. Otherwise, she's going to pick from bag B. Okay? So, how many ways lead to a yellow ball being picked? How many ways lead to a black ball being picked? Okay? So, 2 different questions. Same diagram. Everyone can see the colors, right? Okay. I want you guys to figure this one out. Both of these, A and B. So, to get a yellow, oh wow. For a yellow ball to be picked, the only way a yellow ball can be picked is if what happens? If they roll an odd, because that's the only way that they're going to be able to pick from bag B. How many different odd numbers are there? There's 3. So if they roll any one of those 3 numbers, they're picking from bag B. Bag B is where the yellow ball is. And then how many yellow balls is it? 1. So you have 3 and 1. Am I going to add those together? I'm going to multiply those together. So there are 3 ways for it to be picked. 3 odd numbers times your 1 yellow ball gives you 3 different ways. Okay? But a black ball, what are the different ways that a black ball can be picked? Odd. I would may not picking from bag B, and there's how many black balls in bag B? So 3 odd balls, 1 black ball. What am I going to do to those? Multiply them. So that is what? 3. But aren't there black balls in bag A? So how can I pick from bag A if I roll a what? How many evens are there? 3. How many black balls are there? 2. Okay. So how many is that? 6. So there's 3 ways if I roll odd and 6 ways if I roll even. How many ways are there total? Questions? How are you on this product principle, the sum principle? Okay. Well, if you're taking the ACT this weekend, hopefully this helps a little bit. Okay. Along with this next concept that we're going to talk about. Okay. So, some mathematical problems about arrangement and combinations involve a counting technique that uses the following sequence, which is n times n minus 1 times n minus 2, so on and so forth, until you get to 3 times 2 times 1. Okay? What this basically represents, and this exact same thing is on the next slide, is used with factorial notation. Factorial notation is the exclamation point that you see highlighted in red. So when you see n factorial, n represents some integer, some number, okay? Then basically what you're doing is you are multiplying that number times 1 less, times 2 less, times 3 less, all the way till you're getting down to just 2 times 1, okay? This pattern allows you to calculate expressions with very large numbers, okay? And this, again, is known as factorial notation. All right? So, this is factorial notation. Again, n represents some integers. So, if you have 5 factorial, it'll be written just like that, 5 with an exclamation mark, okay? That's not an error, okay? That actually means that you are performing the series of multiplications. You'll have 5 times 5 minus 1. What's 5 minus 1? 4 times 5 minus 2, which is 3. And it continues all the way down till you get to 1. 5 times 4 is what? Times 3 is? Times 2 is? And of course, times 1 is itself. Okay? So 5 factorial equals 120. So let's say you have 5 letters that you're putting, that you need to, 5 letters that you can't repeat, and you're trying to fill in 5 spots, right? You would use factorial notation to figure out the number of different ways that you can arrange those 5 letters without repeating. Does that make sense? All right? So instead of going through and literally writing out A, B, C, D, E, A, B, C, E, D, instead of writing every single one of them out, you already know by using factorial notation, it's 120 different combinations of arranging those 5 letters. Okay? Now, this right here, what you see here, is your standard formula. Another way that can be written is n times n minus 1 factorial. Because after n minus 1 comes n minus 2, comes n minus 3, and so on and so forth. Okay? Everyone okay? Understand that? Have you ever seen factorial before? Some of y'all have, some of y'all haven't. Okay, so this is something a little new. Waiting for this day. Waiting for it. Okay? Now, quick question. What's 1 factorial? 1. What's 0 factorial?
It does exist or it doesn't?
It does. It's equal to 1. Okay? It's equal to 1. So, 1 factorial breaks down to be 1 times 0 factorial. Well, the only way that 1 factorial can equal 1 is if 0 factorial equals 1. Okay? So, there you go. A little bit of a TOK added into math class. A little bit of TOK added into math class. Let's find the value of these expressions. We're going to do all of these by hand, and then at the end, I'm going to show you how to do these in your calculator, because there is a factorial feature in your calculator to do. Okay? So, long way. 7 factorial means what? It means the product of 7 all the way down to 1. What does 5 factorial stand for? 5 times 4 times 3 times 2 times 1. Notice anything between the top and the bottom? They have 5, 4, 3, 2, 1 all being multiplied together that we can cancel out. And the reason why we can cancel this out is because they're being multiplied. Okay? That's the only time we cancel things out. So 7 factorial divided by 5 factorial is the same thing as saying 7 times 6, which is what? 42. No need for a calculator to do this. It's all right there. Okay? Now, one thing that I could have done instead, I could have said 7 times 6 times 5 factorial, right? Because that would have been 5 times 4 times 3 times 2 times 1, right? All over 5 factorial. Then I could have just canceled the 5 factorials, right? Okay? It's kind of like basically taking that alternate form and expanding it to where I need to stop. So then that way I can cancel some things out. And that's really what's going to happen here with a lot of these, okay? They're going to have things in common between the numerator and denominator when you are evaluating. Okay? Let's look at B. Well, actually, I want you guys to do B on your own. And then we'll do C together, and I want you to try D on your own. What you guys get for your answer? 1 over 20. Yes, it's 1 over 20 because you basically have 3 factorial all over 5 times 4 times 3 factorial. When you cancel things out, please don't make that mistake. There's still something at the top. It's a 1. Okay? So you have a 1 over 20. Let's look at C. Okay? I have 8 factorial times 4 factorial. No, that does not become 32 factorial, nor does that become 12 factorial. Don't try to do some type of operation between the two. You leave them separate. Okay? But what I can do, can I cancel some stuff out? You think? What can I rewrite to cancel some things out without having to write out everything? 10 times 9 times a factorial, right? So a factorial times 4 factorial, 10 times 9 times a factorial. My a factorials cancel out. So really and truly, I'm left with 4 times 3 times 2 times 1 all over 10 times 9. Yes? Now, couldn't I simplify this a little bit more? How so? Without multiplying everything out and then reducing.
The 9 and the 3 simplify.
The 9 and the 3 simplify, don't they? How many times does 3 go into 9? And 3 goes into 3 one time. Can I simplify anything else? 2 and the 10. How many times does 2 go into 10? 5. And if you reduce before you multiply, you won't have to reduce at the end. So now at the top, you really have 4 times 1 times 1 times 1, which is what? 4. All over 5 times 3, which is, so you have 4, ooh, you have 4 or 15. 4 ooh. And ooh. We good? Try D. Try D.
Mental multiplier.
Yes. Okay, go for it, John.
What'd you get? 1?
Not exactly.
Big numbers.
I got
1 over 720 for that.
I got 1 for the 4,320. Yeah.
Should be 4320. Yes. Because the 7 factorial is going to cancel out with the 7 factorial if you expand the 10. And then the 5 factorial is going to cancel out when you expand the 6. So these go and those go. So you're just left with 10 times 9 times 8 times 6. All of that underneath 1. Okay? How do you feel with factorial? Good to work with it? Let me show you how to do it in your calculator. Okay? In your calculator, clearly you need a number to take the factorial of, so let's just do 7 factorial. Okay, so we're going to do 7. Now to get factorial, you want to go to math, you want to go over to prob, and it's option 4. If you have an older calculator, it's probably PRB, same thing. You go to option 4, it looks literally like how it would on your paper, and then there's 7 factorial. If I wanted to divide 7 factorial by 5 factorial, remember alpha y equals, option 1 gives you that fraction, or you just do old school division. I just want to make sure y'all remember that trick. It's very helpful. Okay, remember math, PRB, or prob, 4 over 5 factorial. Looks just like it was for the first one. And there you go, 42. Okay? Very nice. Now, let's take it up a notch. Okay? Yes, we need to take it up a notch because 1, this is HL, not something lower. Okay? So, I want you guys to try to simplify the following. Both of them, okay? If you get stuck on one, go to the other one and see if you can actually simplify this. Okay, it is using the general N. Okay, so think of the formula. And give about 5 minutes before I jump in. Okay, so because N plus 1 factorial is just one step above N factorial, okay, as I showed you here on the board, I could rewrite that N plus 1 factorial to be what? Like this N is this N on the outside. How can I rewrite N plus 1 factorial? Say it again. No. Okay?
Question.
Answer.
Where do you end with N plus 1? You don't? You just
I mean, like, you would go to 3, because at certain point, whatever N is, you're going to get to the point where it's going to be 3 times 2 times 1. Like, you're going to reach an N. if you knew what n was. But in general, this is how you would represent it. Okay? Now, I'm going to say this again because I guess I don't think everyone fully understood me. N, if n was 6, right? N plus 1 would be what? It's just one more up from n, right? So n plus 1 factorial would start at its highest number, and then it would continue to go down. And it goes down by subtracting 1 each time. So if I subtract 1 from n plus 1, what do I get? N. And then if I subtract 1 from n, that gives me n minus 1. If I subtract 1 again, that gives me, and it continues on until you get to 3 times 2 times 1. Okay? So I can rewrite n plus 1 factorial like I see here as n plus 1 times n minus 1 times n minus 2, and so on and so forth. But I can represent this entire thing how? As n factorial. Did everybody see that? So this turns into n plus 1 times n factorial all over n factorial. What do you see? You can cancel them out, and you're left with what?
Or n squared
N squared plus, not 1. Technically n if you distribute, but you don't have to. You can leave it just like this. Questions? Okay. Now this next one, okay? I'm gonna erase this back half here. It's in my way. N factorial minus parenthesis n minus 1 factorial all over n plus 1 factorial. Okay? What can I do here?
We can try to say
And
That's true. Oh. That implies we have a choice.
the bottom we can turn into that. Yes. Okay. Can I use the shorthand method and say n factorial times n plus 1? Okay. What can I do at the top? What do you mean?
well, there's negative in front of it, and then n minus 1.
N factorial is what you see over here in the green. Is there another way I could represent n factorial? Say again.
N times n minus 1 factorial.
Yes. All of this is like saying n minus 1 factorial, right? Because I will continue to subtract 1. So n factorial is the same thing as saying n times n minus 1 factorial. And now I have this at the top. And you might say, well, that didn't make it any better, but it did. It did. What do you
Two.
in the numerator specifically, what do you see? Yeah, we got a factorial there. And there's a technically an n in front.
You can factor out the n minus 1 factorial.
Can I cancel out n minus 1 factorial because I have two terms in my numerator that have the exact same factor? So you have an n minus 1 factorial that's in common between both two terms. If I take an n minus 1 factorial out of both of those terms, what am I left with?
N minus 1.
N minus 1. What can I do from here? So close. What can I do from here?
Can you break the n factorial into n times n minus 1 factorial, kind of pulling out the n minus 1 factorials?
Y'all see that? And don't just say yes because you want me to write. I need you to see these things. If you don't, then we have an issue. What can I do from here? I heard it faintly. Say louder.
Can you cancel the n minus 1 factorials?
Sure can. So then I'm left with n minus 1 all over n times n plus 1.